Hello guys, welcome to this channel. So today we will be discussing about the data transfer instructions in the 8 to the 51. But before going to details of 8 to the 51 instructions, if you didn't access my playlist on 8 to the 51 architecture, just go through it. This is the playlist, bookmark it and save the playlist and you can access it anytime. There are different types of instructions in 8 to the 51. So those instructions are the data transfer instruction, byte level logical instruction, arithmetic instructions, bit level instructions, jump and call, rotate and swap instructions. So data transfer instructions are nothing but we will be studying about the move, push, pop, exchange instruction. In byte level logical instruction, there are AND, OR, XOR, NOT operations. In arithmetic, there will be add, subtract, increment, decrement, multiplication, division, decimal address accumulator instruction. Bit level, which performs on a single bit of bit addressable memory or any SFR. So there are some bit level instructions which are AND, OR, XOR, NOT, complement, clear and set B. Then there are call, unconditional jump, conditional jump, and then there are rotate, left, right, with, without carry and swap instructions. So now first we'll be focusing on the data transfer instructions. So in data transfer instruction, the first instruction is the move instruction, which copies the data from one location to another location. Basic format of a move instruction is destination comma source. The data from the source is copied into a destination. So basically it's not moving the data, but it performing copy operation. The duplicate copy of the source data is created in the destination. So after execution, source and destination have the same data. So there are different types of move instruction. Move, which is a simple instruction. Move X, move C. Move X is used for when you want to access the external RAM. Then move X is used, and move C when you want to access external RAM. In that situation, move C instruction is used. Okay, so those are the mnemonics of move instruction. Move A comma hash n. N is the immediate data. So this immediate data is loaded into a accumulator. Move A comma R, so which copies data from specified register into accumulator. Move R comma A, it's basically performing the reverse operation of a second instruction. It's copying data in accumulator into specified register. Then it is moving immediate data into a register, and then it is moving 16-bit immediate data into DPTR, which is also a 16-bit register. So if you look at the example, move A comma pound or hash 0E1H. So there is a convention which you have to remember. Pound sign indicates that's a data, immediate data, and when any immediate data or address is starting with letter, you have to put a 0 before it. That's why there is a 0 before the E. And hash sign indicates that's the immediate data, so it's a 8-bit immediate data which is loaded into accumulator. So before execution, let's assume A is having 0, and after execution of this instruction, A will be loaded with E1. In another example, move A comma R1. So the register could be anything. There are 8 registers in a register bank, R0 to R7. So among those 8 registers, any register could be used over here. So basically the 8-bit data from that specified register, which is here R1, to A register. So it's copying 8-bit data from R1 to A register. So let's assume that A is having 0 before execution and R1 is having 43. So after execution, A will be having 43 and R1 will also be having 43. Next instruction is move R1 comma A. So basically here the 8-bit data of accumulator will be copied into R1. Here we assume that A is having 05 before execution and R1 is having 43, and after execution this 05 is copied into R1. So now R1 is having the same data as A accumulator. So all of you remember that the register could be any register among 8 registers. So there are 8 registers in each register bank, R0 to R7. So instead of R1 there could be R0, R2, R3, R4, R5, R6, R7 also. Another example, move R2, comma, pound 0E5H. So I hope you remember the convention. So that's immediate data, 8-bit immediate data. So this immediate data will be loaded into specified register, which is here R2. So let's assume before execution of this instruction R2 is having 43, but after execution of this instruction R2 will be loaded with the E5. When there is a immediate data in the instruction and that immediate data is to be loaded into any register like R1, R2 or accumulator, that immediate data is of 8-bit. There is another variation, like you can also load a 16-bit data directly, but in DPTR only. So example here is move DPTR, comma, hash 0ABCDH. So ABCDH is the 16-bit data. You don't have to consider this 0. Why 0 is here? Because of A. A is the later, and when any immediate data or address is starting with later, you have to put 0 before it, and that's why we don't have to consider this 0. So our 16-bit data is ABCD. This instruction is loading 16-bit immediate data into DPTR register. So we know DPTR register is further divided into DPH and DPL, which can be separately accessed. So let's assume before execution DPTR is having 05 and 43 in DPH and DPL in its higher and lower byte respectively. But after execution, after loading this immediate data into DPTR, the DPH would be containing AB and DPL will be having CD. So always remember that we cannot have a immediate data as a destination. Since it is a move instruction, data is move or copied from source to destination. So you cannot put immediate data as a destination. One important thing, register to register moves occur between register A and any one register among R0 to R7. Suppose if you want to move data from R1 to any other register in the same register bank like R3, so there is no such instruction like move R3, R1. This is not a valid instruction. So every data movement goes to the accumulator. Suppose if you want to move data from R2 to R5, so first you need to move that data into accumulator, and from that accumulator you have to copy the data into R5 register. Then there are external data transfer instructions. So far what we have seen are the internal memory access. What happens when there is external memory is connected to the 8051? When external RAM and ROM is connected, there is one instruction MOVX. This instruction is used to access the external memory. So external memory could be as large as 64K, because the address, the width of the address is a 16-bit. So using 16-bit microcontroller can access 64K of memory. So when there is a need to access external memory where data is stored, move X, this is a variation of the move instruction is used. So X is added to move to indicate that data movement is external. From the external memory you are fetching the data. So there are two variations, MOVX A, @RP and MOVX A, @DPTR. So RP is a register pointer, and we have already seen which two registers are the register pointer among the 8 registers. Okay, so basically here the content of RP is a 8-bit and content of DPTR is a 16-bit. So first instruction, copy the content of external address which is provided by this register pointer. So from that memory location data is copied into accumulator, and in the second instruction it copies the data from the external address which is provided by the DPTR register into accumulator. So DPTR here provides the 16-bit address and RP provides the 8-bit address. So other instructions are the reverse operation. Here what we are doing, this memory location is acting as a source here, but here the memory location is acting as a destination. So every external move operation is performed along with the accumulator. No any other register is used. So first example, move XA, @R1, or if you don't want to use R1 you can go for R0. So it's copying the content of external address which is given by the R1 to accumulator. So let's assume some data over here. Initially A is having 05, R1 is having 43. So the content of R1 here is 43, which is nothing but the address. The data of R1 will be treated as the address, and from that memory location the data will be fetched. So at this address 43 there is a 22 is the 8-bit data is stored. So this is the scenario before the execution, and after the execution the content of this memory location will be copied into accumulator. As you can see, it's highlighted here. Next instruction is the MOVX A, @DPTR. So DPTR is a 16-bit register which is giving you 16-bit address, so you can access 64K of memory location. So it copies the content of the external address in a 64K of memory location which is provided by DPTR to accumulator. So it's copying content of that memory location into an accumulator which is provided by the DPTR. So let's assume here some data. So initially A is having 05, DPTR is having 0543. So the content of DPTR will be treated as address, 16-bit address. So our 16-bit address would be 0543, and let's assume at this location 56 is stored. So before the execution, this is the scenario, and once you execute this instruction, that 56 which is stored at this memory location is copied into accumulator. So notes to remember: every external data moves always involve register A. No any other register like R1, R0, R2, R3 are used for external data movement. MOVX deals with the external RAM and IO addresses. RP can address to 56 bytes and DPTR can address up to 64K bytes. So suppose if you are connected externally, if you are connected to 56 byte externally, you can use a RP. Otherwise, if you are using full capacity of 8051 and if you interface 64K of memory externally, then you can go with the DPTR. This instruction is used to fetch the code from the internal or external RAM. So if you want to know the details of MOVC, you can watch the previous video in which a MOVC instruction is properly explained. So using MOVC, data is moved from the code memory which is the ROM, to the accumulator. So accumulator is always involved when there is an external movement. So this is all about the data transfer instruction. If you like the video, hit the bell button, comment and share.